Space and Science News. With James. Our journey through the cosmos begins with a perplexing question that has haunted scientists and dreamers alike for decades. In the vast expanse of the universe, teeming with countless stars and potentially habitable planets, why haven't we encountered any signs of intelligent alien life? This enigma, known as the Fermi paradox, challenges our understanding of the universe and our place within it. As we gaze at the night sky, we're confronted with a deafening silence. But what if this silence isn't just a matter of distance or timing? What if there's a fundamental limit to how far any civilization, including our own, can advance technologically? Today, we'll be talking about the universal limit to technological development, because why not? This theory suggests that every intelligent species in the universe, no matter how advanced, eventually hits a ceiling in their technological progress, one that falls well short of the ability to colonize an entire galaxy. Let's dive deep into this subject and explore the cosmic barriers that might be keeping us alone in the universe. In the depths of the cosmic night, a question echoes through the minds of astronomers, philosophers, and dreamers: where are they? Amidst the billions of galaxies, each harboring billions of stars, surely we can't be alone. Yet, as our telescopes scan the heavens and our radio dishes listen for whispers from the void, we're met with an eerie silence. This cosmic conundrum, known as the Fermi paradox, has puzzled humanity since its inception. Named after the renowned physicist Enrico Fermi, it asks, if the universe is so vast and old, why haven't we detected any signs of extraterrestrial intelligence? But what if the answer lies not in the stars, but in the very nature of technological progress itself? What if every civilization, no matter how advanced, eventually reaches a point beyond which it cannot grow? This is the premise of the universal limit to technological development hypothesis, or ULTD. As we embark on this intellectual journey, we'll explore a provocative idea that challenges our assumptions about progress and the destiny of intelligent life in the cosmos. Could it be that the silence we perceive is not due to our isolation, but rather a fundamental constraint that affects all technological civilizations? Let's begin by reflecting on humanity's own technological journey. In less than 7 decades, we progressed from having no powered flight to walking on the moon. It took just over a century to advance from the first basic computer to pocket-sized devices that grant instant access to the sum of human knowledge. This breakneck pace of advancement has led many to assume that our technological capabilities are boundless. We dream of colonizing Mars, building megastructures in space, and one day venturing to the stars. But what if this optimism is misplaced? What if there's a universal ceiling to technological progress that no civilization can surpass? The discovery that habitable worlds are common throughout the cosmos has only intensified our curiosity. If our solar system is young compared to the rest of the universe, and if humans could potentially achieve interstellar travel someday, shouldn't we have seen evidence of other intelligent entities spreading throughout the galaxy by now? This puzzling absence of alien contact or observable galactic civilizations forms the core of the Fermi paradox. Named after physicist Enrico Fermi, who reportedly posed this question in 1950, it continues to challenge our assumptions about life in the universe. Enter the hypothesis of a universal limit to technological development, or ULTD, proposed by Antonio Geles Filho, a researcher in public policy at the Getulio Vargas Foundation in Brazil. This theory suggests that every intelligent species in the universe eventually reaches a point where further technological advancement becomes practically impossible. If the ULTD hypothesis is correct, it would mean that there has never been, is not currently, and will never be anything resembling an interstellar civilization or even an interstellar conversation between different alien species. This idea challenges our long-held beliefs about the potential for advanced alien civilizations and our own cosmic destiny. The ULTD hypothesis is based on several key observations: the history of human civilization's rise and fall, the increasing difficulty and cost of scientific projects that expand our knowledge, and the apparent lack of technological intelligence elsewhere in the cosmos. These factors suggest that we should be cautious about assuming that the technological capacities of humans, or any other intelligent beings, are limitless. This concept of a universal technological ceiling doesn't just apply to humanity. According to the ULTD hypothesis, any intelligent civilization in the cosmos would eventually face the same scenario, regardless of their ingenuity or determination. To understand the ULTD hypothesis, we need to consider the relationship between knowledge and technology. Nobel Prize-winning physicist Richard Feynman once said, What I cannot create, I do not understand. This suggests that our technological capabilities are fundamentally constrained by our knowledge of the universe. While there are natural limits to human technology, such as the speed of light barrier, there may also be natural barriers to human knowledge, aspects of the universe that remain forever beyond our grasp due to the limitations of our biology and cognition. We've created remarkable tools to extend our senses and analytical capabilities, from microscopes and telescopes to powerful computers. However, these technologies come at an ever-increasing cost. Consider the massive scientific projects of our time: the Large Hadron Collider at CERN, with its $4.75 billion construction cost and $286 million annual operating budget, the International Space Station, requiring $3 billion per year to maintain, or the international effort to achieve nuclear fusion at ITER, estimated to cost up to $20 billion for construction alone. These endeavors demonstrate that pushing the boundaries of human knowledge demands increasingly enormous investments of energy and resources. Moreover, the rate of fundamental scientific breakthroughs appears to be slowing. The last major advances in our understanding of the universe, relativity and quantum mechanics, are nearly a century old. While our knowledge has certainly deepened in many areas, we haven't seen comparable paradigm-shifting discoveries in recent decades. This deceleration in scientific progress, coupled with the escalating costs of research, suggests that we might be approaching a limit. At some point, we may have to make difficult choices between pursuing cutting-edge scientific research and addressing more immediate societal needs. The ULTD hypothesis proposes that as civilizations advance, they encounter an uncrossable gap in their quest for knowledge. This gap manifests as an exponential increase in the energy required to conduct experiments that could lead to significant scientific breakthroughs. Imagine a scenario where testing a new unifying theory of physics requires a particle accelerator the size of the Milky Way galaxy. The energy and resources needed for such an endeavor would be astronomical, potentially exceeding the capabilities of even the most advanced civilization. This energy barrier isn't just a matter of scale. The ULTD hypothesis suggests that the relationship between energy input and scientific output isn't linear. There comes a point where the energy required to make the next leap in understanding increases so dramatically that it becomes practically impossible to cross that threshold with existing technology. Since the laws of physics are believed to be constant throughout the universe, this uncrossable gap would apply to any intelligent civilization, regardless of their level of advancement. No matter how ingenious or determined a species might be, they would eventually confront this fundamental limitation. This concept challenges our assumptions about the potential for interstellar civilizations. If every technologically advanced society eventually hits this barrier, it could explain why we haven't detected signs of galactic-scale alien civilizations. The energy requirements for such expansion might simply be beyond the reach of any species, no matter how advanced they become. The ULTD hypothesis doesn't just consider technological limitations, it also takes into account the societal challenges that come with increasing complexity. This aspect of the theory draws lessons from the rise and fall of human civilizations throughout history. As societies become more complex, they add layers of specialization and infrastructure to produce more energy and resources for continued growth. Think about the difference between a hunter-gatherer society with its limited social roles, and our modern industrial society with its vast array of specialized professions and intricate economic systems. Initially, this increasing complexity leads to greater productivity and advancement. The development of agriculture, for instance, allowed for food surpluses that supported new societal roles and further technological progress. However, this complexity comes at a cost. As societies become more intricate, they require increasingly expensive infrastructure and energy inputs to maintain their complexity. Joseph Tainter, an archaeologist who studied the collapse of complex societies, proposed that civilizations reach a point where the returns on societal complexity begin to diminish. The cost of maintaining and expanding the complex systems that support advanced technology eventually outweighs the benefits they provide. Gelesfilio applies this concept to technological civilizations throughout the universe. He suggests that the infrastructure required for advanced space technology is just one part of overall societal complexity. As these civilizations push towards interstellar capabilities, they may find themselves struggling under the weight of their own complexity. This perspective offers another potential explanation for the Fermi paradox. Many non-terrestrial societies might have collapsed due to the diminishing returns on societal complexity, even before they reached the limits imposed by energy requirements for advanced scientific research. Despite the sobering implications of the ULTD hypothesis, it doesn't completely rule out the possibility of detecting signs of extraterrestrial intelligence. While the theory suggests that no civilization can achieve sustained interstellar expansion, it allows for the existence of what Gelesfilio calls castaway technology. Imagine a scenario where a civilization, before reaching its technological limit, launches probes or sends out signals into space. These artifacts of a bygone era could continue to traverse the cosmos long after their creators have hit their developmental ceiling or perhaps even ceased to exist. Our own Voyager 1 probe serves as a perfect example. In 100,000 years, it will still be silently crossing our galaxy, a testament to human achievement even if our civilization no longer exists. Similarly, we might one day detect or even retrieve alien Voyagers, long-dead probes from distant civilizations that have long since reached their ULTD. The famous WOW signal, detected in 1977 and never fully explained, could potentially be an example of such a cosmic message in a bottle. These isolated signals or artifacts wouldn't represent ongoing interstellar civilizations, but rather the last gasps of technological societies before they hit their universal limit. Gelesfilio likens these potential communications to messages in bottles cast into the cosmic ocean. Like a stranded captain on a remote island trying to signal the outside world with limited resources, advanced civilizations might make final attempts to reach out across the vastness of space before they reach their technological ceiling. This perspective offers a bittersweet view of our search for extraterrestrial intelligence. While we may never encounter thriving interstellar civilizations, we might still find echoes of past achievements, distant whispers in the cosmic darkness that remind us we're not alone in our struggle against the limits of technology and knowledge. As we contemplate the ULTD hypothesis, we must consider its implications for humanity's own future. If there is indeed a universal limit to technological development, what does this mean for our dreams of becoming an interstellar species? The theory doesn't necessarily doom us to eternal confinement within our solar system, but it does suggest that our visions of galactic empires and faster-than-light travel might be overly optimistic. Instead, we might need to recalibrate our expectations and focus on maximizing our potential within the limits we face. This perspective encourages us to think more critically about our current trajectory. Are we approaching our own technological ceiling? How can we best allocate our resources and energy to continue advancing our knowledge and capabilities? Perhaps most importantly, how can we ensure the long-term survival and flourishing of our civilization within the constraints we may face? The ULTD hypothesis also highlights the importance of sustainability and efficient resource management. If we're working with finite technological potential, it becomes even more crucial to use our resources wisely and maintain the delicate balance of our planetary ecosystem. Moreover, this theory underscores the value of every scientific breakthrough we achieve. If we're approaching a limit to our understanding, each new discovery becomes increasingly precious. It encourages us to celebrate and fully utilize the knowledge we gain, rather than always looking to the next horizon. Ultimately, the ULTD hypothesis provides a sobering reminder that our species' destiny is not predetermined. Whether or not this theory proves correct, it challenges us to think deeply about our place in the cosmos and the true nature of progress. As we continue to explore the universe and push the boundaries of our knowledge, we must remain open to the possibility that the greatest frontiers may lie not in the stars, but in fully realizing our potential within the limits we encounter. The universal limit to technological development hypothesis presents a thought-provoking perspective on our place in the cosmos. It challenges our assumptions about progress and the potential for intelligent life in the universe. The idea that every civilization might eventually hit a technological ceiling raises profound questions about our future as a species. Antonio Gelesfilio's insights remind us that while we've made remarkable advancements, the road ahead may not be as limitless as we once thought. The complexities of societal growth and the increasing costs of scientific exploration could hinder our progress, just as they may have done for other civilizations throughout the cosmos. Yet, this theory doesn't extinguish all hope. The possibility of discovering castaway technology or signals from distant civilizations offers a glimmer of optimism. Perhaps, in the vastness of space, there are echoes of past achievements waiting to be uncovered. This exploration of the ULTD hypothesis invites us to reconsider our approach to technological advancement and resource management. It encourages us to value each scientific breakthrough, not just as a stepping stone to interstellar travel, but as a significant achievement in its own right. We hope this journey through the cosmos and contemplation of these profound questions has sparked your curiosity. If you found this exploration intriguing, please consider subscribing to our channel for more thought-provoking content. Your support helps us continue to delve into the mysteries of the universe. Remember, the greatest frontiers may not lie in the stars, but in fully realizing our potential within the limits we encounter. Let's keep asking the big questions and searching for answers together. Until next time, stay curious. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.